This is an A-level pure question on solving differential equations. A scientist is studying a population of mice on an island. The number of mice, n, in the population t months after the start of the study is modelled by the equation n is equal to 900 over 3 plus 7e to the power negative 2.5t, where t is a real number and it's also greater than or equal to 0. Part A, find the number of mice in the population at the start of the study. So at the start of the study, t is going to be equal to 0. So we're just going to substitute t equals 0 into the equation. So we have n is equal to 900 over 3 plus 7e to the power negative 2.5t, and that's going to be 0. Now what's going to happen is, where we have anything to the power 0, which is what we've got here, then this bit just becomes 1. So we'll end up with 900 over 7, or 3 plus 7. In other words, 900 divided by 10. So n is going to be 90. So this is the number of mice at the start of the study. Part B, show that the rate of growth dn dt is given by dn dt is equal to n times by 300 minus n over 1200. Okay, so first thing I'm going to do is to rewrite this as a product so that I don't have to use the quotient rule. And there's no need to use the quotient rule because top is a constant, it's not a function of t, so that would be too much work to use the quotient rule. So we're going to write n as 900 times by 3 plus 7e to the negative 0.25t to the power of negative 1. So now we can differentiate this by using the chain rule. Actually, I know it's a product, but this is a constant again. So if I differentiate the outside of this bigger bracket here, I'll have negative 900 times by 3 plus 7e to the negative 0.25t. Remember, the inside doesn't change. And I've got power minus 1. You take 1 away from the power, so it becomes negative 2. And then what I need to do is 2 times by the inside differentiated. So that's going to be this differentiated. So the 3 is going to go, and this will become 7 times by negative 0.25t, which I can write as negative 7 over 4 e to the negative 0.25t. Now my negatives are going to cancel out, the negative 900 and the negative 7 over 4. And now what I need to do is to write dn dt as, and I'm going to move this negative power back to the bottom of the fraction again. So I've got 900 times by 7 over 4. Let's move that bracket a little bit. E to the negative 0.25t over 3 plus 7e to the negative 0.25t all squared. Now if I have a look at what I've got here, this what I need to get to is all in terms of n, so I need to use this to substitute all of these e parts to get them back in terms of n. Okay, so let's do a little bit of side working over here. So I want to get at this denominator, so I'm going to do the reciprocal of both sides. So I'll end up with 1 over n is equal to 3 plus 7 to the negative 0.25 t over 900, and then I'll multiply both sides by 900, so the 900 will now become the numerator over here. And so I can replace 3 plus 7e to the negative 0.25t with 900 over n. Now that's what I've got in the denominator here, and it's squared. So I can now write 900 over n all squared. Now for the numerator, I've basically got something very similar here, but I've got 7 over 4. Now what I'm going to do, just to make things a little bit easier, I'm going to take that 4 out. So I'll write 900 over 4 here, which will then just leave me with 7e to the negative 0.25t. So in other words, I can take what I've just worked out here, and if I take 3 away from both sides, I'll end up with 7e to the negative 0.25t. So that's what I can now put here in the bracket. So the bit in the bracket here with that 4 taken outside will be this equivalent to 900 over n minus 3. Right, now from here I can see I've got a 900 at the top here and a 900 here. I can cancel out this 900 with one of the 900s here because it's going to be 900 squared, and that will leave me with just a quarter here. And then what I'm also going to do at the same time, I'm going to put these two together. So if I write this as let's say 3n over n, so I'll just put it in, so 3n over n, like that. Then I can write 900 minus 3n all over n. And then in my numerator, remember one of those 900 is gone, so I'm dividing by not 900 squared, but 900 over n squared. Let's multiply at the top, so we'll get 900 minus 3n all over 4n. Now it's going to be divided by this fraction, so that's going to be times by the reciprocal of that, n squared over 900. This n and the n squared will cancel out. I can also divide this top here and this bottom here by 3. So if I do that, I will end up with 300 down here, 300 here, and just n. So that will give me n times by 300 minus n all over 4 times by 300, which is 1200. So we've got the result as required. The rate of growth is a maximum after t months. Part C, find according to the model the value of t. Now we want to find when dn dt is a maximum, that's the growth rate. And we find when it's a maximum when the next derivative, d squared n over dt squared, is equal to 0. So we're going to take what we had from part B and we're going to differentiate it and set it equal to 0 and find the value of n. So let's write it in a form that's just going to be a little bit easier to differentiate. So dn dt, write that as 1 over 1200 times by, and we'll expand the brackets here, 300n minus n squared. So that's just basically this written a different way. We'll differentiate that, so d squared n over dt squared. So what will happen here is when I differentiate this, I'll have 300. So I've got this constant here. So I'll basically have 300 over 1200. I can see that's going to cancel down basically to 3 over 12, which is going to be a quarter in a moment. And then minus, so if I differentiate this, that's going to become 2n with this constant here. So that will be 2n over 1200. Let's just simplify that and see what we get. So 3 over 12, as I said before, is a quarter. So we've got a quarter minus, and this will be n over 600. And I set that equal to 0. That means that I have n over 600 is equal to a quarter. That means that 4n is equal to 600, which means that n is equal to 600 divided by 4, which is 150. So let's just highlight that. So this is the value of n for which dn dt is a maximum, because dn dt's derivative is equal to 0. We set it equal to 0. So we'll now substitute that value of n into our formula where we have t. So we'll basically have 150, that's n, is equal to 900 over 3 plus 7 e to the negative 0.25t, and we want to solve for t. We'll start by dividing both sides by 150, so we're left with 1 here, and we're going to be left with 6 here. So, and then multiply both sides by this denominator here. So I'll have 3 plus 7e to the negative 0.25t is equal to 6. Take away 3 from both sides and then divide by 7. So I'll have e to the negative 0.25t is equal to, so I'll have 6 minus 3, which is 3, divided by both sides by 7. And then we'll do the log of both sides. So that will mean that negative 0.25t is equal to the natural log of 3 over 7. Next we'll times both sides by negative 4. So I'll have t is equal to negative 4 times by the natural log of 3 over 7. Now we don't need to worry about this being a negative, because when we do a log of a decimal here, number smaller than 1 greater than 0, we're going to get a negative. So let's do that. We should get a positive answer, and I get 3.38919. Okay, now they've used big T, so let's use big T. So T is equal to, and we'll give it to 3 significant figures, 3.39. 3 significant figures. Now remember, this is months. Okay, so we've got our value for T highlighted, and we'll move on to the next part of the question. It says, according to the model, the maximum number of mice on the island is P. Part D, we need to state the value of P. Now, whenever you get a question that says state a value, it means you can write the answer down without any justification or working. Right, okay. Now we can look at our value for n and just see what happens after a long period of time. Now in the original model there's t here, so as t tends to a large number, then this e part is going to tend to 0. It's going to get smaller and smaller and smaller, which means that this whole bit here, the 7e to the negative 0.25, and it had the t before, we can ignore. It's just going to be too small to make a difference. That just leaves us with 900 divided by 3, which gives us a value of n equal to 300. So as I said, we can just state that answer. If the question says state, you do not need to justify why you have given that answer. So n is 300, not 300n, it's not newtons, just 300.